Not quite used to going after Steve. Usually I go after Marta in presentations, and so I don't have to adjust anything. But thank you, Steve, for that really perfect introduction to my talk, because I want to switch gears a little bit and talk about something that is not specific to a particular pest or pathogen, but something that I think is a little more fundamental to integrated pest management, and that's nutrition. Because like in human health, what you eat greatly influences how healthy you are. So I'm going to be talking about some work that we've done in my lab. So Jeff and Lene and I have been doing some experiments down in Lethbridge, looking at different supplemental protein feeds. And I just want to start by acknowledging Pullman apiaries. I don't know if it's my wisdom or knowledge, but probably most likely my just plain dumb luck and Jerry's wisdom. But we've been very fortunate to work with them, and they've been very generous in sharing not just, from their pocketbook, but also their bees and their time and their knowledge. So I want to thank them for that. So we're going to be comparing different protein patties. These are commercially available products that are available to you to feed your bees. But I want to take a step back to start by thinking about what do bees actually need. We all know that bees need nectar or honey. That's their carbohydrate source, but that's not the complete picture for what a bee needs, not only as an adult, but to complete a full life cycle. Bees need water like other animals. They need the carbohydrates, but they also need proteins and fats and vitamins and minerals. They need a breadth to their diet, and pollen is the food source that provides not only the protein, but also the lipids and vitamins and minerals that they need to rear larvae. And so the quality and the quantity of pollen that a colony has coming in affects not only the number of eggs, but also, and more importantly, the proportion of those eggs that are reared through their full life history to adulthood. And the pollen supply affects the number of workers that the colonies can rear, which affects subsequently their adult population. So when do they need it? When do they need protein supplementation? Well, beekeepers supplement the pollen diet of their colonies either during a dearth period when there's just nothing that produces pollen blooming. That could be with additional pollen or with a pollen substitute. And so that's avoiding some of the problems we associate with a dearth, whether it's cannibalizing the brood or shortening the larval pupal period and capping the brood early. They also do it to improve the performance of their colonies beyond what the natural environment can support in that particular time and place. So we heard Jerry talk yesterday about his strategy of getting out and treating and feeding in March. And so that's what they're doing here. You can see they're putting on pollen patties and putting in some apivar strips. And I actually presented this slide in California, and they laughed when I told them this was spring, but it seems normal to me. So this graph just shows the effect of spring protein feeding on worker populations. So this is data from Ontario, but I think it's pretty typical of what we see across the world, really. And what it shows is the cumulative number of workers that are reared in that colony from mid-March towards the end of April. And the bottom line, which is blue, is colonies that were pollen limited. So they had a pollen trap on them. And what you see is pretty intuitive. They were able to rear fewer workers. The middle line is the control, the green line, and that's just colonies that were allowed to forage for natural amounts of pollen, and they're intermediate. And the ones that were supplemented with additional pollen, in this case, were able to rear more brood through to adulthood during that period. I think most beekeepers know that. If you feed bees, you get more bees. But what do you feed them? There's a dizzying array of options. I get this question so often. What should we feed our bees for protein? How much? How often? For how long? Should it be dry? Should it be a patty? Should it be a liquid? What's the safest for the bees? Because with any feed you're giving them comes a risk of transferring disease. In fact, that's how we experimentally inoculate colonies for some diseases, is through proteins, patties. There's also a risk of giving your bees pesticides in feed. But you also want to know what's the best diet for your bees. What do they need for vitamins and minerals and proteins and lipids and fatty acids? But if you have 3, 5, 10,000 colonies, cost is an important part of that decision-making process as well. So what's going to give you the greatest return on your investment? If you're spending $1 more on a patty and you times that by $25,000 or 25,000 colonies, it quickly adds up, right? But then there's also considerations like, what are your beekeeping goals? Is your goal to have a really big population at a certain time point, to hit a certain honey flow? Maybe you're a hobby beekeeper and you don't really want huge populations in your backyard. You just want really healthy bees. So you got to consider all of these things when you're deciding how, what, and when you're going to feed your bees. And beekeepers that are considering supplementing their colonies have to balance these things. They have to balance the cost of labor and materials against both the short-term and long-term gain, because maybe you feed your colonies these supplements, and in the short term the colonies are larger, but by July 1st it doesn't matter, the other ones have caught up. But also pollen flows vary. They vary regionally, they vary among apiaries, and they vary among seasons and years. So you've got to have all of this in your head when you're making these decisions. So part of the sort of rationale for looking at some of the treatments that I'll talk about in a bit was to look at an option to pollen. Pollen is, of course, the bee's natural food source, but I think it was Steve who showed that iotron was irradiating 500,000 kilograms, if I'm remembering correctly, 500,000 kilograms of imported pollen. And so we import a lot of that pollen from China, and they have a different regulatory environment, different pesticide use, different landscape. So the idea is, what is a pollen substitute? So not a supplement, but a substitute, something we can feed our bees that doesn't contain pollen, that's effective in stimulating colonies to rear brood, but it also still has to be palatable to bees, right? They have to want to eat it, and it has to be nutritious for them. So pollen substitutes may pose less of a disease risk. They may or may not be less expensive, depending on the product, and they're going to have different pesticide residues. So these pollen substitutes are still plant-based products, and oftentimes they'll have a different pesticide profile than what you would have from a pollen. So the purpose of this specific study was to evaluate these commercially available products, things we can buy, by measuring consumption and colony growth, so that's both the area of brood production as well as the adult bees, in a commercial operation, using sort of management that makes sense to them for bees that are going to be pollinating canola seeds starting in late June. So I think most people in this room are probably pretty familiar with hybrid canola seed pollination, but it's an interesting crop because the pollination and the major honey flow coincide. Not all pollination markets are very good for honey flow, but canola is. And so it's especially critical that you have your peak population at that time point, because it's both your pollination money, your pollination income, as well as your honey income all at the same time. So the design of this experiment, Jerry talked about the singles. He's overwintering in his wintering building, so he brought them out directly from the wintering building to a holding yard. They were all in one yard. And then we experimentally fed them these patties for 4 or 5 weeks, depending on the year. And then we did a cluster score to evaluate the colony size in mid-June, shortly before they went to pollination. We also assessed the brood and adult population. We removed any colonies if they had queen problems, because obviously you can't compare brood, for example, if it's queenless. The first year of the study, we also noted the queen source, because it's written on the bottom boards if you're listening to Jerry's talk. And then you can see in the photo the yard was barrel fed, and we did this last year and the year previously. So the particular treatments that we used were Feed Bee, which is a plant but not soy-based, and it's really difficult to get information about these actual products. They don't have to list the ingredients. We also used Global Patties, and that was both the 15% pollen, so it included pollen, as well as the 0% pollen. And then we used a product made by a company called Alltech, which is called Bee Pollinate, but it has no pollen in it, so it's a bit of a confusing name. And that was also in Jerry's talk. He mentioned Global 15% and Bee Pollinate, so that's the product he was talking about. And then we evaluated some Mega Bee patties and a treatment we call Trio. So this was actually a choice treatment where the colonies had 3 smaller patties within each colony, and they had the Feed Bee, the Global, and the Alltech product, and they could choose what they got to eat. And this is what it looked like in the bee yard. So it's a palletized system. You have 4 colonies on a pallet. The first year, 2018, we had a 25% bee pollinate treatment, a Feed Bee patty, a Global 15% patty, and then the Trio, the choice of the 3 patties all in the colony. And I should add that they all had as much of each of the patty types as they wanted, because we were replacing them and weighing to see how much they had eaten. So for those of you who remember 2018, it was a really late spring. But once spring came and we were able to get the bees out, it was like everything started blooming 2 days later. So there was abundant natural pollen. And we also had a really beautiful river bottom yard that year. So it was a really beautiful spring yard. There's lots of stuff available. 2019, we switched our treatments a little bit. We had the bee pollinate, which remember has no pollen in it. The global 0%, which has no pollen in it. The global 15% pollen. And then Jerry was kind enough to let us do a control, which had no patty. So what happens if we don't feed them? And last spring it was earlier, and there was little natural pollen, and we said, Jerry, give us a terrible, crappy yard. And so he did, and there was just nothing there for the bees to eat. So then we assessed the brood area, and we did a cluster size score before treatment, 2 weeks into the treatment, and then after we were done feeding them. And then we did it, as I mentioned, shortly before they went into pollination. This is just a shot of what those trio colonies looked like. So you can see in the top photo on the left is the 15% pollen patty, in the middle is the feed bee, and on the right is the Alltech product. And those are pretty typical of what we saw in that trio treatment. And then we would replace the patty before they ran out. So this first graph shows 2018 results, and it shows the total patty consumption. And I should be honest and say I don't actually know that they were eating it. They could have just been taking it and tearing it out and throwing it in the bush. But, you know, the patty was going away and the bees were growing, so I'm assuming it's consumption. So we had the bee pollinate treatment, the feed bee, the global 15%, the mega bee, and the trio. And the first thing you'll notice is that the feed bee bar is lower, which means that they ate less of that feed bee patty that we made. The important result, I think, from this is that if you look at the bee pollinate, the global 15, and the mega bee, there's no difference in consumption. They ate the same amount of all of those three treatments, which kind of surprised me, I'll be honest. I thought they would prefer the one with pollen and eat more of it, but we didn't see that. And the other surprising result was how much of the trio they ate. So even though all of the colonies could eat as much as they want, when they had those three different patty types in the same colony, they ate more. So this just narrows in on that trio treatment to show you the consumption of the patties that were on the same colony. And what we see is, again, they ate less of the feed bee. So they ate less of the feed bee when they had a choice. They ate less of the feed bee when they didn't have a choice. But there's no difference between the pollinate and the global 15%. This graph shows you consumption, again, in terms of kilograms per day, but over the whole time period that we were doing this experiment. So there was no bloom at all when we brought them out. But then shortly the bloom came on, and you can see as the pollen flow gets stronger and stronger, we do see the bees consuming less of the patties, but they didn't stop. They did keep eating it. And at all time points except the last one, we saw they were consuming more of that trio treatment, and at all time points, definitely they were eating less of the feed bee. But the other three were fairly similar. So it was consistent across time. So this graph shows the cluster size, and the dark bars on the left show the initial cluster size before we started, and they were all similar, which is what you want. So our treatments when we started, all the colonies were similar, but they were all similar when we started. So the colonies all grew, but they all grew equivalent amount regardless of what we fed them. And this is the cluster score shortly before we moved the colonies for pollination, and I just colored sort of if it's below 17 frames of bees, I colored those ones red. And if it's green, that means it was above 17%. And the take-home message is that basically all of the colonies, except for a few duds, were pollination grade by the end. But it didn't matter. Treatment didn't matter. What we fed them didn't matter. They all grew. This shows the amount of capped brood. And when we first brought them out, again, that's the dark boxes along the bottom, there was virtually no brood, just a tiny amount of brood, kept brood. And then when we were done the feeding treatment, there was 500 or 600 square inches of brood in all the colonies. There's some variation around that, but it's unrelated to the feed treatment that we had given the colonies. There was also no difference in brood patchiness. And we know brood patchiness, as if you listen to my talk on Monday, brood patchiness leads to the amount of brood in the colony, leads to the number of adult bees you have later on. And there was no difference in what we were feeding them in terms of the solidity of the brood pattern. They were all pretty good. The few ones that had a lot of misses, it was more related to disease, but it seemed unrelated to feed treatment. But we did see differences in stocks, which was a little reassuring because it meant at least our methods were capable of detecting differences if they were there. So the one stock at both time points had lower brood patchiness. It had about 11% when we started, and then about 6% by the end of the feed treatment. So they did have a decrease in the patchiness of the brood, so the brood got more solid. And that was true for both of the different stocks, but overall, for both the whole time period, one of the stocks was patchier than the other. And that, of course, perpetuated itself into the total amount of brood. So in terms of the increase in capped brood between those two time points, with the stock that was less patchy, so it had a more solid brood pattern, there was not only more brood, but the increase was larger in brood production between those two time points. So this is data from this spring, 2019 data. Remember, we switched treatments up a little bit. And you can see that in this graph of cumulative consumption of the patties over the 4 weeks we were feeding them, there was no difference between the global 15% patty and the bee pollinate 20% patty, which has no pollen. They were statistically indistinguishable. But one result that surprised us was that the global 0% patty actually was consumed at a slightly higher rate. And we found that a bit mystifying, so we sent the patties in for some analysis, and we found out that the global 0% had been made with a sugar syrup that was higher in sucrose, whereas the 15% in the pollinate had been made with a sugar syrup that was higher in glucose and fructose, and bees have a preference for sucrose. And so the sugars that you're putting into your patties are going to affect how attractive they are to bees and how much the bees eat. If we looked at the cap brood area, and this is just the data from the post-treatment, so after we fed them, again, there was no difference in the treatments between the global 0%, which has no pollen, the global 15%, which has pollen, and the pollinate, which has no pollen. But the controls were much, much lower in terms of how much brood we were able to rear. So that, I think, it's important to confirm. I don't recommend other people do it, but we do know, you need to feed your bees, and we can tell you how much difference it makes. And in this particular apiary, in this particular year, it made a big difference. There was much less brood in the colonies that weren't supplementally fed. This graph shows the cluster score 6 weeks after we stopped feeding them. And again, no difference regardless of what we fed them, as long as we fed them. But that decrease in brood area by not feeding them in the controls perpetuated along into the actual cluster score pre-pollination. And this is pretty typical. I know you can't read this graph at the back, but don't worry about it, because the take-home message from this is if you look at the leftmost two graphs, those were experiments done in the US without naturally available pollen in a complete pollen dearth. And what we see during those experiments is that we do see differences in cluster score and brood area among protein treatments. But once there's a natural forage or natural pollen flow on, those treatment differences vanish. So with naturally available pollen, there's no effect of patty type on the brood area or the population that they're able to rear. So what can you take home from this talk and actually apply? Feed your bees. Patties are necessary, at least at some sites and some years. Jerry talked about differences he sees between his farms up north and farms down south. And Steve and I have run experiments where we have replicate protocols in Beaverlodge and Lethbridge. And it seems, generally speaking, like feeding protein is more important in the south. And I think that's because we have fewer woody plants that are spring pollen sources, so fewer trees and shrubs. The groups in this experiment that they received patties in 2019, they had 6 times more capped brood than the controls that didn't receive patties within 2 weeks. And so that resulting lack of brood production, it results in decreased adult populations later on. both for pollination or for honey production. Consumption rates are not necessarily indicative of increases in brood production or productivity of your colonies. So if you want a human health example, I love chips. I could eat a whole family pack of Doritos, but that does not make me any healthier. When there's some pollen available, pollen supplements and pollen substitutes may be equally productive. So these pollen substitutes, in this case, did support brood rearing as well as a patty that contained pollen when we provided it to these colonies in the spring. But there's different costs, different risks of vectoring disease, different pesticide exposures. And so these are all things you need to think about when you're deciding what and when and how to feed your bees. So this coming spring, we're going to do it again one more time, and our treatments are going to be global 15% with pollen, global 0% without pollen. We're gradually, slowly reducing the amount of bee pollinate because it's expensive, so if we can make a cheaper patty that does just as well, we're going to do that. We may also try the Healthy Bees product. I don't know if anybody remembers from Apimondia, they had a big booth, and they had these crazy looking black patties. That's an algae-based product, and I've seen zero data on how well it actually performs, so I want to try that one as well. So thanks to Pullman Apiaries, Rhonda Tygeson was our summer student. She was here yesterday. Jeff and Lene, of course, and especially Jeff, who was there for both years. Global Patties, Alltech, and as always, the Alberta Beekeepers Commission for their support. Any questions?